Hey, Katie.
Hi, Ben.
Hey, I feel like something's different.
Oh, the audio quality is fantastic today, and there's no lag.
Actually, I don't know if the audio quality is fantastic because you and I are actually sitting in the same geographic location for the first time in a very long time.
Many months.
In a little conference room in Facebook.
Yep. It's beautiful here.
Yeah, well, kind of. But both walls are whiteboard, so we could scroll things and we'd be the only people hearing this audio to see them. I mean, this is a podcast.
Sounds extremely effective.
Anyway, we're going to talk about something, I don't know, but first, you are listening to Linear Digressions. Okay, what something are we going to talk about? That was a crazy intro.
Mm-hmm. So this was inspired by a listener who is also named Ben.
Mm-hmm.
I don't know how to say his last name. I'm going to try real hard.
A third Ben?
There's many Bens in the world.
Are you serious?
They're all involved in this podcast. This particular Ben, I'm going to guess his last name is Ostigi. Does that look like a good guess?
Something like that.
Okay, well, you know who you are. Thanks for the idea. He was asking a really good question, one that I've been thinking about a lot lately, which is about if using machine learning and related types of analyses is totally fair when you're using them to make decisions about people. On the one hand, numbers are numbers, and we like to think that computers are objective and they don't have the biases that humans have. On the other hand, there's increasing amounts of work and awareness that center around the fact that the data that you send into these algorithms does have sort of our human and social biases baked into the data. And then the algorithms learn to discriminate in the way that, discriminate with like in the bad way. So sometimes we say discriminate and it means just tell an apple from an orange.
Yeah.
Here we mean discriminate in the sense of like be a little bit racist or reach conclusions that are not what we like to think of as, fair conclusions.
There have been all kinds of stories about this in the news, about bots learning to be not politically correct or just outright offensive.
We should talk about that, actually. Let's go on that digression. What are you talking about when you say that?
There was a Microsoft bot.
A Twitter bot.
Twitter bot, yeah. Which was basically programmed to behave like a teenager. Mm-hmm. And the data set, do you remember what the data set for it was? Well, was it the interactions that it had with people, so when people responded to it?
I think that was primarily where it was supposed to learn. The neural net, I think it was a neural net, had been trained and it was kind of ready to go, but
right.
The inputs were comments that were tweeted at it, and then it would watch what people were saying on Twitter, either from being tweeted at directly or being kind of looped in on people tweeting back and forth, and it would watch those conversations and learn to sort of participate in the same parlance as those conversations.
Right, and in this case, the racism came from its training set, which was the people interacting with it. So it came from literally humanity itself, right?
Yeah.
The humans. And it didn't take long for it to devolve from where it started to where it ended up when they pulled it offline.
Oh, it was up for, a day?
It was it was short.
And it was saying terrible things.
It was saying really, really terrible things.
Things that were so bad that I will probably just say we shouldn't even talk about exactly what it was saying, even in a joking sense, because it's really pretty bad.
Yeah. So, moving on.
So
anyway, this has been in the news.
Yeah, so I guess it underscores a little bit that machine learning algorithms are kind of like impressionable children in some ways, and they learn
I haven't thought of them that way,
them.
yeah.
Yeah, so turns out if you're a terrible person to your children, there's a good chance that your children will learn to be terrible people. And in this case, yeah.
With humans, they may just end up exactly the opposite of you. It's like a roll of the dice.
That's
They're like,
true.
oh, God, my parents were horrible. I'm never going to be like them. But,
humans have
maybe
a little
that's
bit more agency than...
the better side of humanity. As opposed to bots, neural nets don't have a sense of right or wrong other than what you give it.
That's right. Neural nets don't usually have a moral compass or other ways that they can be socialized properly or whatever. Good teachers. I don't know.
Right.
All the things that can save you as a human. Yeah, so that was, I think, very instructive, actually, was how quickly that Microsoft experiment just went off the rails. And it's I think, given a little bit more of a nudge to this conversation about discrimination in data sets. And so what are some of the things that I'm thinking of when I say that? One example is, like, let's say you have a machine learning algorithm, and this happens all the time, an algorithm that's supposed to, it's being built by a bank, and it's trying to figure out if someone should be approved for a loan or not.
Yeah, right.
And so you have a bunch of characteristics of the people who are applying for loans, and also a lot of historical data about people who have applied for loans in the past and what their rates have been like in paying things back on time, or if there are any particular characteristics of an individual that means that they'll be more likely to go into default or miss payments or these sorts of bad things. And so the thing that's really interesting is, number one, there's a simple thing that you can do if you don't want your loan approver to be racist. Let's start from the assumption that you don't want to be discriminating against any racial group. And this is true of many different ways that you can sort of slice the population demographically or whatever.
That's a good starting point.
Yeah. So let's start with the assumption that you don't want it to be making racial discrimination type decisions. So you say, okay, I'm going to train this algorithm, but I'm not going to train it on any features that are your race. So that's just not going to be something that's available to it.
Right.
But what you might also say, very reasonably, is one piece of information that I do think might be relevant is, let's say, something about the quality of the neighborhood that you live in. So let's say it's like a mortgage, and we find that houses in certain neighborhoods, because let's say the neighborhood is having some problems, or the schools aren't very good, or there's something about the neighborhood that we think is feeding into the fact that there's problems with mortgage defaults in that neighborhood. So let's put in that geographical information, and we want to take that into account.
Right. There's a problem there.
Yeah.
There have been so many studies and papers and infographics and everything exploring how populations become more racially discriminated geographically over time.
Yeah.
There are clustering effects.
Exactly. And so even though you're certainly not trying to put in racial information, in fact, you're going out of your way somewhat to not make it explicitly aware of someone's race, it can still figure it out. It doesn't know that's what it's doing, but it can totally figure it out.
Right, because there are linkages, there are patterns there.
Exactly. So if you think about someone who's watching the output of this algorithm that you've just built, it almost, depending on the details of the data and stuff, it almost doesn't matter whether you send in race as a column or not. You get back something that looks like you did, because It's finding race, it's just finding it in other places.
So we've talked before about anonymizing data sets before and how difficult that problem is.
Yeah.
This feels like a similar problem. Like, how do you remove that element? How do you anonymize your data set to someone's race? Because that data might be encoded in so many other fields in your data.
Yeah, I think right now, as far as I'm aware, that's not something that we really know how to do.
Right.
To remove it entirely, so that there's nothing in a data set. I mean, I guess what you can do is you can take out all the data. We can have a mortgage algorithm that is based on entirely like your favorite flavor of cake, and I don't know what's something else that we think is uncorrelated with your race. Like,
Yeah, I don't know.
Yeah, it's hard to think of something that you're like, oh, there's no way that could be correlated with your race or your gender or your age, like everything like this.
And it's not even something that if a human thought they could do, they actually could do.
Yeah, so there's maybe some technical things that I could think of. I would bet that none of them would work.
That's optimistic.
Yeah, well, it's tough. You're trying to take algorithms and say, do as I say, not as I do, but all you can do is show them examples of what you've already done, and so, like, how is it supposed to learn anything else?
Yeah.
So I think there are a couple things that give me some hope here. First is that it's early days. I think there was a lot of thinking, even just a few years ago, that this problem didn't exist for machines because machines are objective in ways that humans maybe aren't. Now, machines themselves are objective, but sending in human-based patterns, basically.
Right.
That's, I think, where most of the problem arises. So the fact that we're even aware of this as a thing that can happen is progress.
So we're on the right track.
I hope so.
Step one, at least.
Step one. Step two is, I think there are more and more places, the places that are particularly prone to this stuff, places like that handle hiring, like resume screening. That's a huge problem in resume screening. Bank data. I could probably think of more, but you get the idea. Those places are starting to add post-processing steps that explicitly check. What they'll do is they'll take their predictions and then they'll actually start splitting up all the data based on the demographic characteristics that you didn't want to append, but now you can
that's interesting.
You append them on.
So they'll basically run the numbers and then run the numbers again in a discriminatory way and compare them and see if they're running the numbers in their non-discriminatory way is actually non-discriminatory?
I don't know that they're doing that. What I was thinking was a little bit like, let's say you run the numbers in a way that you're hoping is non-discriminatory.
Right.
And that means not including a column like someone's race or their gender. Then you append on the race and the gender columns and you say, okay, all of the people that I approved for a loan, what are their race and gender characteristics? All the people that I denied, what are their race and gender characteristics? And what we're saying here is fair is that those rates should be equal or something, and at least that you should be aware of, if there are imbalances that seem to be correlated with your race or your gender.
Got it.
But you heard me maybe get a little bit squishy there when I was trying to define what a problem would look like. And I think that's because it's inherently, like, at the inside of this, once you peel back all the layers, it's the question of what do we think fairness is? What should fairness look like? Does it mean that people of all races and all genders get approved at identical rates? If so, how do you get from where we are right now to that point? How do you deal with it if you think that someone is not going to have a good outcome from making them this loan or making them a job offer, but you still need to, you feel obligated in a sense to give them that opportunity because that's what we've said is fair and we want to be fair. So I think that makes this actually a really deep problem, is because we don't know what the solution looks like. If we knew what the solution looked like, if we had something we all agreed on was like, this is what a fair outcome looks like.
Yeah, then we could go implement it.
Yeah.
But it's not just so what I'm hearing is it's a deeply difficult technical issue and it's also an issue of definitions.
Yes, I think that's fair. And there are places, there are places where we know that I think we picked one of the harder angles to look at this, something like a mortgage approval or a job offer. There are other things where it's pretty obvious that, a certain technological solution is not ideal and they've found ways to deal with that. So when I say that, I'm thinking of this example. There was an app that was deployed in Boston, and it was an app that you have it on your phone, and then it watches sort of the phone accelerometer, and if it sees kind of a jostle, it will figure out where you are in space, and if it sees jostles on many phones in the same location in space, on roads in particular, it says like, oh, we think there's a pothole there, and let's send out city services to patch the pothole. Yeah, very cool. What they realized was that they were finding all the potholes that are in places that are traversed by young rich people who have smartphones.
Right, who have smartphones.
So the solution that they found for that, and so places that weren't as well off or that had older people, they weren't seeing the same rates of their potholes getting repaired because they didn't have a way of sort of automatically notifying the city in the way that the phone-based systems did. So what they did was they just attached phones like that or similar kinds of data collection operations to municipal services, which then go all over the city in a much more evenly distributed way than people just driving in their private cars. And that solved the problem.
That worked.
Yeah. So there's also stuff like that it's just like, if you know to be checking for this, sometimes the solutions are very apparent and you just have to find ways of getting data that isn't as biased.
Linear Digressions is a Creative Commons endeavor, which means you can share or use it any way you like. Just tell them we said hi. To find out more about this or any other episode of Linear Digressions, go to lineardigressions.com. And
And if you like this podcast, go ahead and leave us a review on iTunes so other people get to listen to this content too. You can always get in touch with either of us. Our emails are ben@lineardigressions.com and katie@lineardigressions.com in case you have comments or suggestions for future shows. You can tweet us at lindigressions. Thank you for joining us, and we'll see you next time.